Hello viewers, this is Timas TV. Today we are looking at network graph theorem. It's a technique where we can apply to give solution to electrical circuit. We have something like this where we have some branches, we have impedances and the source. We can actually transmit this circuit into a graph with a guiding rules. And one of those rules is that all the impedances, all the impedances, this is resistors, inductors, capacitors, branch. If you are seeing this, that should be presented as branch. And also all the current sources is open circuit. All the current sources is open circuit. All the voltage sources are branches. And when we have this idea, we also have to note the number of branch. You have to note the active node in your graph. So at this point, we acknowledge this. Between here and here is branch. You also have between here and here, it's also branch. We have a node here, so we can actually join this. Can join this. Can join this. And also extend this. This will give us 1, 2, 3, 4 nodes. So at this point, we can use this as branch 1. This will be branch 2. This is branch 3. We have branch 4. Branch 4. I also have 5. And finally, we have 6. But you have to also note the direction of current. So we are taking this in this direction. We have this, we have this, and we have this. So at this point, we successfully transmit this circuit into this. And we also acknowledge the number of branches and also the number of nodes that is there. So in actually doing that, we can also represent a tree of this graph of this circuit. A tree must have all the nodes. So we can actually have this. We can have this. We can have this. You can see that we have 1, we have 2, we have 3, and we have 4. So this is considered to be your tree where we have some missing branch. The missing branch, you can also write them, that can form your link of this graph. So in this point, we can also have one of the very important metrics we can form from this. We call that incident metrics. So incident metrics have to do with a branch and also the node of the network. So in this situation, we have 1, 2, 3, 4, 5, and we have 6. So these are the branches. We also have nodes. Nodes we have 1, 2, 3, and also 4. So when the branch is moving towards a particular node, we have that to be -1. And when it's moving away from the node, that is 1. And when a particular branch is not involved with a given node, that is 0. So we want to look at an incident between node 1, that is here, and also branch 1. So you can see that it's moving towards the node. So we have this to be -1. So the same thing still on node 1. So let's also consider branch 2. Branch 2 is moving away from it, so we can call it 1. And branch 3 also moving away from it, this is 1. 4 does not have anything to do with branch node 1, so it is 0. And the same thing as 5 and also 6. So we want to consider node 2, that is here. And we realize that branch 1 is 0 when compared to node 2. And also branch 2 is -1, it's moving towards the node. 3 is 0. We also have 4. 4 is moving away from it, and that is 1. We have 5. 5 is moving towards it, and also 6. 6 is 0. We have that. So let's consider nodes. 3. Node 3 with branch 1 is 0. Node 3 with branch 2 is 0. That of 3, we have -1 is moving towards that. 4 is 0. 5 is away, and 6 is away. We have 1, 1. So at this case, we also look at the situation of node 4 and the rest of the branches. So at this point, we look at 4. This is 1. It's moving away. We have branch 2 has nothing to do. Branch 3, nothing. Branch 4 is moving towards branch 5, nothing, and branch 6, this. So this is what we call incident matrix of this graph. This is the incident matrix of this graph. So let's write it out. The incident matrix is incident matrix of this. We have 0, 0, 1. We have 1, -1, 0, 0. We have 1, 0, -1, 0. We have 0, 1, 0, -1. We have the 0, -1, 1, 0. We have finally, we have 0, 0, 1, -1. So we call this the incident matrix of this graph. So this is very important because it is one of the important components that we will need when we are solving for a particular circuit. So when we also talk of the number of tree that we can form from a certain graph, recall that we pick this to be our tree. We pick this to be our tree, where we consider this, and this. So it means that the twist is actually branches that constitute 3, 3, 4, and 3, 4, and 5. Whereas the length is actually length of this is actually the missing branches. This is 1, this is 2, and this is 6. So these are some of the key parameters that we need when we are trying to analyze circuit using network graph theory. This is very important, and we also need to know the number of trees that is possible from a given graph. Recall that the branch will have to be with the derived from the source, the impedances, and also the number of nodes in a given circuit must be taken note of, and the branches also which also notes the directions of current. I want to believe that this was helpful when we are actually solving our circuit using network graph theory. Thank you very much.